Hi everyone and welcome to this video. Welcome to this AS Physics course, and right now we're starting with the first chapter, which is physical quantities in units. So the first idea that we need to be aware of is what are physical quantities really. For example, if you were to go on and Google what is physics, you would see something like this, that this is the study of the physical world or some physical quantities around us, and that is in itself not very self-explanatory. So if we were to talk about what physical quantities really are, I can just present the requirements of physical quantities in two checkboxes. Now, what are physical quantities? Those can just be summarized in these two conditions which say this. So the first condition says that any physical quantity must have a magnitude. So this is the first condition which must be fulfilled. Now, if this is not your first exposure to physics, you already know what magnitude means, which is just the number, or you can say the size associated with any reading. Any quantity that we are talking about will have some number associated with it. For example, a time of 5 seconds, a mass of 6 kg, a length of 10 meters. You all see numbers with all of these examples. So this means it must have a magnitude. But if I just say something like a temperature of 100, this is not very self-explanatory either. So the other thing it must have is a unit. Now, one thing that I would like to highlight, because this is something the examiner does confuse us with, is that it does not really have to be an SI unit. SI units will also be discussed in a while. It can just be any unit. So for example, if I say a height of 6 feet, this would also be a physical quantity. Yes, feet is not an SI unit, but it is a unit nonetheless. So this is the basic idea behind physical quantities. Now, when we talk about physical quantities, all physical quantities can be broken down into these two categories that we are now going to discuss. So we can say that all physical quantities can be called either as basic quantities, or some might also call them as base quantities, and another type that we will discuss in a while. First, let's just talk about this. So these are the basic quantities, and their units are also going to be called the basic or the base units of these quantities. So in the SI unit system, there are just a total of 7 basic quantities. So let's just write down their names here along with their units. And again, this order is totally arbitrary. This means nothing. I'm just writing down the names of these first. Mass, length, and time. Some of the most important quantities that we all recognize and know of. And thermodynamic temperature. Next we have electric current. The sixth one is called the mole, and the seventh one is something called luminous intensity. The first 5, all of these are going to be discussed in the AS syllabus. The sixth one is going to be discussed in the A2 syllabus, and the seventh one is not going to be touched at all in the A-levels physics course. Now, if we were to also write down their base units, so the units of mass is kg, length is meters, time is seconds, thermodynamic temperature is not degrees Celsius or degree Fahrenheit, it's Kelvin, electric current is in amperes, the mole is unironically also measured in moles, and luminous intensity is measured in a unit called candela, the symbols for which are these. Now, what is the idea of basic quantities? In the SI unit system, what basic quantities really mean is this, that here we have these 7 basic quantities, right? So there are a total of 7, And from these 7 quantities, I can come up with any other quantity. So these basic quantities are basically fundamental or standalone quantities that do not need the help of any other variable to be defined, right? But any other quantity will work off the basis of these, and they will take the help of base quantities in order to be defined. Then it also follows that if you're talking about derived quantities, their units can also be derived in terms of these base units. Now that's what we will basically be doing in this video.
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
But before we go on to this very long discourse on finding the derived units for a lot of the derived quantities, in this video, let's just talk about an example where you'll be asked to determine whether the following are physical quantities. So I'll be giving you a bunch of examples, and for each of these you'll need to use those 2 conditions which were given above, which is that they should have a unit and a magnitude. You'll be using those to figure out whether these are in fact physical quantities or not. Let's start with the first one. So if we are talking about a mass of 0.45 kg, this is the question: is this a physical quantity or not? So does it have a magnitude? Yes. Does it have a unit? Yes. So this is a physical quantity. On to the next one. A time interval of 5 hours. Is this a physical quantity or not? Do I see a magnitude? Yes. Do I see a unit? Yes. It's not SI, but it doesn't make a difference. It is a unit nonetheless. So this is also a physical quantity. Number 3. If I say, and this is a quantity you would have studied in O-level physics, and this is also something we will be covering in AS physics as well. Let's say an efficiency of 63%. Is this a physical quantity or not? Do I see a magnitude? Yes. Do I see a unit? And the answer is no. The percentage sign is not a unit. It just means it's a 63 out of 100. Another way to say this would just be 0.63. So this is not a physical quantity because this does not have units. Similarly, let's do this last example. Would this quantity have physical units or not? Sine of 30. Now, some of you might be tempted that there is a magnitude, there is a unit, but the unit is of the angle, not of the sine of this thing. Just to put matters into perspective, let me show you something here. So sine 30, I know is going to be half. This is also something you use a lot in O and A level math. But let's say if I just ask you to recall that the first time you must have seen sine, cos or tan in math, what was the name of that chapter? If you can recall appropriately, the name of that chapter was trigonometric ratios. Because if I'm talking about a right angle triangle, I can say that the sine of that thing, of that angle, is going to be the ratio of the side opposite to the angle to the hypotenuse. Now, let's say this value was like 2 meters and this value was like 4 meters. Just as we can cancel the numbers out, here the units would also get cancelled out. So we can see that the final thing does not have any units. So this would also not be a physical quantity because it has no units. All right. So in the next video, we'll be going through the different quantities and we'll be trying to find out their base units. See you there.
Hey there! If you found this A-level physics lecture helpful, why don't you head over to altacademy.org and sign up for the full A-level physics course. You can sign up for physics, chemistry, biology, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for? See you there.